Alright, so to solve right triangles, first we got to have some standard way of labeling a right triangle, and we do. And I've shown it to you, but I haven't shown you how to name the angle measures. So to be a right triangle, remember we're going to have this little square here in the corner. And if we call this side A, this side B, and this side C, then the angle directly across from it is going to be also the same letter, but it's going to be capitalized. So you see how side A is across from this angle up here, so that's going to be angle A. And side B is across from this angle here, so that's going to be angle B. And side C is across from this angle here, so that'll be angle C. But angle C is always 90 degrees because it's a right triangle. Now we don't know what angle A or angle B are equal to, not yet at least. Okay, so it depends on the problem. Remember that angle A plus angle B plus angle C has to be equal to 180 degrees. So if we know that C is always equal to 90 degrees because it's a right triangle, then angle A plus angle B always has to be equal to what? 90 degrees. All right. So, and we also know the Pythagorean theorem, c squared equals a squared plus b squared, or a squared plus b squared equals c squared. Okay. So I'm going to show you how to solve for sides, and I'm going to show you how to solve for angles. All right, so first, let's look at a problem where we can solve for a side without using the calculator. I'm sorry, not a side, but an angle measure without using a calculator. But you will have to use a calculator here. So I'm going to go ahead and bring up a calculator. And you need to make sure it's in degree mode. So if it's in radian mode, change it to degrees. Alright, and the first problem that we're going to look at, and I'm just copying these are examples in the book. Alright, so here's the first problem. So let's say we had this triangle. So if I wasn't given the triangle though, I could still draw a triangle like this. I would just be told that I had a right triangle and angle A is equal to 40 degrees and B, side B, is equal to 2. And then of course we know angle C, that's equal to 90 degrees if we need to use it. Alright, so what we need is we're going to need our formulas for right triangles. So we need these formulas here. And as long as we know two, like think about each part of the formula as a variable, as long as we know two of the three, we'll be able to solve for the one that we don't know. So we never want to set up a problem where we have two variables that we don't know. We only want to set up a problem where we have one variable that we don't know. So right away, the first thing that I see that I could solve for would be angle B, because I know that angle A plus angle B is equal to 90 degrees. So if angle A plus angle B equals 90 degrees and angle A is 40 degrees, so 40 degrees plus angle B is 90 degrees. Subtract 40 from both sides and you'll see angle B is equal to 50 degrees. So we could do that without even using a calculator. Alright, now we need to solve for side A and side C. So what we're going to do is I would use the given angle measure just in case you mess up on finding angle B for some reason. Maybe I subtracted wrong or something. So I'm going to use this given angle measure. So that means that the side across from it, that's the opposite side. And the side that touches it, that's not the slanted side, that's going to be the adjacent side. and then the slanted side of the triangle is going to be the hypotenuse. So for this particular problem, if I use this as my theta, here's opposite, here's adjacent, and here's hypotenuse. Alright, so as long as I can't use a formula with opposite and hypotenuse in it if I go from this angle, because that's two unknowns, that's two things I don't know. So I need to use a trig function that if I'm going from this angle measure, I need to use a trig function that has adjacent in it and then either hypotenuse or opposite. So I know that the tangent of 40 degrees is equal to, remember tangent is opposite over adjacent. So it's going to be equal to A over 2. The opposite side is A, something I don't know. The adjacent side is 2, something that was given. So you see now I have only one variable. So to solve for side A, I would simply multiply both sides by 2. That will get rid of that 2. And so I have side A is equal to 2 times the tangent of 40 degrees. And gotta make sure our calculator is in degrees. So the way that I use the Windows calculator is different from other calculators. So if you have like a TI calculator, you can actually push the tangent button before you put in the 40 degrees. But this calculator, I have to put in the 40 degrees before I push the tangent. So it's 2 times, and then I have to put 40 tangent equals. Now, again, if you're using a TI calculator, you can probably just type in 2 times tangent and then put in 40 and then equals. So I got that side A, if I round to 2 places, is 1.68. So I'm going to put my approximation symbol here. It's approximately 1.68. Now I don't want to use side A to help me solve for side C, because I rounded side A and I don't want to plug rounded values into a formula. So what I want to do now is, if I use this angle measure again, I want to use the trig function that has adjacent, because I know that side, and hypotenuse. So that's what? Cosine, right? Cosine is adjacent over hypotenuse. So the cosine of 40 degrees is equal to the adjacent side over the hypotenuse. Alright, so I need to solve for side C. That's the only unknown that I have. So I'll multiply both sides by C first, and that will cancel that C out. So I have C times cosine of 40 degrees equals 2. That's side C. So to get side C by itself, I divide both sides by the cosine of 40 degrees. So side C is going to be approximately, I need to take my calculator, and I'll say 2 divided by, and then cosine of 40. And on my calculator, I have to hit equals after I do that. So if I rounded that to 2 places, I'll get 2.61. So it's approximately 2.61. Now let me show you what you have to do if you don't know any of the angle measures except for one. Alright, so on this one I was given an angle measure. I was given 2 angle measures, so it's easy to find a third one. But let's say that I'm not given any of the angle measures. So let's look at this triangle. For this triangle, side A, that's side A, is equal to 3. Side B is equal to 2. I don't know what the hypotenuse is equal to, but I can figure that out, right? So I'd probably do that first. Figure out the hypotenuse since you know the two legs of the triangle. So c squared equals a squared, which is 3 squared, plus b squared, which is 2 squared. So c squared equals 9 plus 4, or c squared equals 13. So I take the square root of both sides, and I get that c is equal to the square root of 13. It's not plus or minus because these are lengths and they can't be negative. If for some reason you wanted to approximate that, you could just go to your calculator and you could say 13, and then in my calculator I put square root. I think if you use a TI calculator, you got to put square root and then 13. So if I rounded that to 2 places, that would be 3.61. Again, I don't want to use that in any of my formulas because it's rounded. Anytime you plug rounded values in the formulas, you create a margin of error. So if you've ever done a percent error in the lab, then a lot of the reasons why percent errors get so large is because we have to measure things by hand, like in a lab, and it's human error. If we measure things as precise as we can, we still can't get it exact. So that was always a pain for me whenever I was taking chemistry. I'd get so mad because I'd have a big percent error because I couldn't measure things, more, I guess, down to maybe several decimal places instead of just 1 or 2. All right, so let me show you how to find an angle measure. I wouldn't use C again to do this. Even you could use the square root of 13, but just in case I mess that up, I wouldn't use C. So I can figure out what angle B is equal to if I say the tangent of angle B equals the opposite side over the adjacent side. So the tangent of B equals the opposite side, which is 2, over the adjacent side, which is 3. All right, so I can figure that out by using the inverse function. So angle B is going to be equal to the inverse tangent of 2/3. So in your calculator, if you have a TI calculator, if you push second tangent, that's inverse tangent. So if you look at the little, at the blue letters on the TI calculator, you see tangent -1. That's inverse tangent. So if you take the inverse tangent of 2/3, you'll get the answer. In my calculator, my Windows calculator, I have to say 2 divided by 3, and then trig. Now I need the inverse functions to come up. So I push second, and it'll do inverse. So if I do inverse tangent, and I have this in degree mode, which I do, it'll tell me how many degrees angle B is. So if I round that to one place, that would be 33.7 degrees. So angle B is about 33.7 degrees. All right. Now, if I want to find angle A, then I'm going to change my angle measure. I'm trying to find angle A, that's up here. So if I go up here, my opposite side is now 3, and my adjacent side is now 2, if I use tangent. So the tangent of angle A is opposite over adjacent, which is switched up because I changed to a different angle. So that's going to be 3 over 2. So I do the same thing. I take the inverse tangent of 3/2, and that will give me angle A. So I'm going to come back to my calculator. Clear it out. I'm going to say 3 divided by 2. We all know that's 1.5. And I'm going to push second tangent. That does inverse tangent. If I round that to one place, that's going to be 56.3. So angle A is about 56.3 degrees. So just to check, if you add angle A, B, and C together, if I said 56.3 degrees plus 33.7 degrees plus 90 degrees, if you do that in a calculator, you'll get 180 degrees. So that's a way to check and make sure that you got it right.